Welcome to my projectbazaar.com. Let us discuss about the resource allocation for multiple sources, single relay cooperative communications or FDMA systems. Let us discuss about the abstract of the product. So, joint allocation of resources, namely subcarrier assignment and power profiles at the source and relay nodes, is considered for both relaying schemes, that is AF and AF. So, there is amplify and forward, decode and forward. So, with multiple users using orthogonal frequency division multiple access, that is OFDMA. So, the objective of this product is to allocate the resource to maximize the weighted summary subject to individual power constraints on each node. So, we formulate such a problem as subcarrier based resource allocation that seeks a joint optimization of subcarrier assignment and power profiles at the source and the relay nodes. So, using the high signal to noise ratio, that is SNR approximations, there are two algorithms are proposed based on the channel gains. So, in the first algorithm, the order of subcarriers are split in two partitions. The first partitions of the order subcarrier are assigned to the one of the users, so whereas the second partition is assigned to the remaining users. So the algorithm is applied repeatedly in the fashion by splitting each second partition into two partitions until the lot partition is split between the last two users. So the partition that maximize the weighted sum rates or then the short. So the proposed algorithm is to reduce the computational complexity compared to the exhaustive search and the dual approaches. So the algorithm is also proposed to reduce the computational complexity, and further it is a two-stage algorithm. So one is a basic stage and another one is a transfer stage. In the basic stage, each user is assigned a subset of the subcarriers based on the ordering function. So in the transfer stage, subcarriers can be transferred between the users to maximize the weighted sum rate. So the merits of the proposed algorithm are demonstrated by the numerical solutions. So these are the abstract of this product. Let us discuss about the flow diagram of the product. First of all, this is a system model, and the system model is split into amplify and forward, that is AF, and decode and forward, that is a DF. So in the amplify and forward scheme, there are subcarrier assignment at the source nodes. So in the subcarrier assignment at the source node are subdivided into two parts. So one is the first partition are assigned to the one of the users, and the second partition are assigned to the remaining users. So these are the process of the amplify and forward. And then the decode and forward, in this process the power profiles are the relay nodes. So this is the process of decode and forward. And then these power profiles at the relay nodes are again to the hysterics. So hysterics are split into two stages. One is a basic stage and another one is a transfer stage. So finally, the first and second partition and basic stage and transfer stage are the performance analysis to find the sum rate of a process. Then the subcarrier assignment of the source nodes, the first partition are assigned to the one of the user. So only one user are assigning to the subcarrier assignment, and the second partition, so other remaining users are remaining to the further process, so that is allocated to the source nodes of the product. So this process is continue until the last partition is split between the last two users. So the partitions that maximize the weighted sum rate are then sought. So the proposed algorithm is of reduce the computational complexity compared to the existing approach. So in this heuristic algorithm is proposed to reduce the computational complexity. So it is subdivided into two-stage algorithm. One is a basic stage and another one is a transfer stage. So in the basic stage, each user is assigned a subset of the subcarriers based on ordering function. So in the transfer stage, the subcarriers can be transferred between the users to maximize the weighted sum rate, finally calculating the sum rate to the performance analysis. So these are the flow diagram of the product. Let us discuss about the running procedure for the product. Click the main file and then run. So the outputs are displayed. So these all the outputs are related to our flow diagram. So in this process, the system under consideration, which finds a penalty for promising application instead of multiple antennas, and hence we consider as a IEEE 802.1 and long-term evaluation. So in the system model, so these are the source nodes, so the key number of source nodes are displayed, and this is the relay node, and this one is a destination node. So in this destination node is one, and this relay node is also one, a single relay node process, and these are the so many number of source nodes are displayed. So in this process, so in the first half, the channel coefficients of the ith user between the source and destination nodes, the source and relay nodes, and the jth subcarrier are denoted by HSD, so that is a source to destination, and then H is that is a source to relay respectively. So in the second hop, the channel coefficients between the relay and the destination node, that the JS packet is relay to destination. So the receive signal of the destination and relay nodes in the first time slot T1 of the ith on the JS group subscribed on the YDY and YRY respectively. So these are the description of the system mod. So in this figure, the system rate of algorithm is implemented by 1, and the exact search algorithm, so that is a k equal to 3. So k is equal to source, so source number of is equal to k equal to 3. So the proposed AF means, that is AF means amplify and forward, and DF means decode and forward. So this is a amplify, that is a amplify and forward. This red is known as a decode and forward. So in the x-axis we get a rate of the process, and the y-axis we get a PR, so power of the rate. So this figure is on the sum rate algorithm 1. So the algorithm is a source number equal to k equal to source. So this is a graph of this second figure. In this figure, the sum rate of algorithm 1 and algorithm 2 also. So as a PR max, so that's a power rate. So AF means same process, that amplify and forward, and DF means decode and forward. So PR in watt, that's a power in watt, and rate in MBVs, in the bits per second. So this is the graph of DF. So it's a AF amplify and forward, and this is the graph of DF. So for this process is processing by the algorithm 1 and algorithm 2 as a function of power. In this figure, the sum rate is a function of the number of the users of the proposed algorithm. So in this proposed algorithm, so number of users are taken in the x-axis, and the rate is taken in the y-axis, that is a bits per seconds. So this is a AF, that is a amplify and forward method, and DF means a decode and forward method. So the sum rate at the calculator by using the proposed algorithm, depending upon the number of users, what number of users, that is a source. So what number of users here we use, and then the sum rate will be calculated. This figure also the same algorithm, but the algorithm is using the third algorithm, that is a dual base algorithm, that is similar for amplify and forward, and also decode and forward. So number of users are here we use, and the rate in MBVs, that's a bits per seconds. So here the amplify and forward method is taken as the red line, and the blue is taken as the decoding and forward. So this procedure is using the dual base algorithm, and the figure is denoted by the algorithm 3 of this figure. So in this figure, the sum rate of algorithm 1 and the exact search algorithm. So here there is a rate and average SNR. SNR means signal to noise ratio in dB, up to -15 to and 30. So this black is denoted the exact with exact SNR, and blue is the proposed with the approximated SNR. So in this SNR, the rate in kbps, that is a kilobits per seconds, and the SNR taking the high SNR in dB. So signal to noise ratio, comparing with the algorithm 1 and the exact search algorithm. So in this figure, convergence of subgradient method as a function of number of iterations. So number of iterations up to 8 iterations, 0 to 9. So there is a 8 iteration. This is a error. How many errors occur in the iteration process? So the convergence of the subgradient method as a function of number of iterations in the error processing. So this is the function of the iteration method. So overall, these are the running procedure for the product. Thank you for listening this video.